Okay, this is a recording over three-dimensional figures from Study Island, and these are the tough problems. These are the problems that you were probably struggling with, and so I'm going to go ahead and work them out now. If a plane slices a cube, let's go ahead and draw in our cube. So if you don't know how to do this, you need to take notes so that you can do this in the future when you're given problems. Okay, it slices a cube through 3 points that are equidistant. Okay, that means that they are equally far from each other, equally distant from each other. From one of its vertices. Okay, you got to know what a vertice is. This is an example of a vertex, and so vertices is just plural. And it says, which of the following best describes the cross-section of the cube? Okay, so from a vertex, and I'm going to choose this one who's looks like it's closest to me. I'm going to choose the one with the pink dot on it. I'm going to estimate equally distant away. So maybe there, maybe there, maybe there. And then I'm going to connect my dots here. And draw in my shape. You can kind of tell. Keep in mind that these are equally distant. That means they are the same distance apart. And so we're going to think about what kind of triangle has equally distant lengths. So a triangle that has that would be an equilateral triangle. So that would be Z. So the answer there is D. Okay, if the rectangular pyramid shown above is sliced by a plane that passes through two diagonal vertices, okay, so it's got to pass through two diagonal vertices. So I'm going to go ahead and pick two of those. I'm going to pick this one, and diagonally means I need to pick one on the opposite side. I'm going to pick that one. And vertices on the base and the top vertex. So the top is going to be up here. Which of the following best describes the cross-section of the pyramid? I'm going to go ahead and draw that in so you can see what that looks like. Okay, so obviously it's not X or Y. And then the triangle that we have drawn is fatter than the triangle that they have for Z. So that answer there is W, and so it is B. Okay, so here is a pretty tough one that you will most certainly not see on the CRCT. It says the cross-sections shown above are from a right rectangular pyramid. Right off the bat, you've got to know what a right rectangular pyramid looks like. Okay, so it's rectangular. That means it's a rectangle at its base, and it's a pyramid, and so that means each one of its faces are triangles. It says cross-section A is from a plane that is perpendicular. Well, side note over here, perpendicular means that if we're talking about to the base, perpendicular means it cuts it straight down. Parallel, maybe what you're more familiar with, means if this is the base, the cut is above it and it does not cross it at all. Okay, so cross-section A is from a plane that is perpendicular to the base and parallel to the front of the base. Okay, so perpendicular to the base and parallel to the front of the base. So that means they cut that off right here. They cut off the front of this triangular or rectangular pyramid. Okay, so we've got 45 feet at the top, 180 feet at the bottom, and it is 90 feet tall. Okay, cross-section B is from a plane that is perpendicular to the base and parallel to the sides of the base. Okay, and you can see that B doesn't go up quite as far. So B is on the side, and he's got 100 feet going on down here, and then 75 feet for that top dimension, and then he is 30 feet tall. Okay, now we get to cross-section C, and it is parallel to the base and intersects the pyramid at 1/4 of the way up. Okay, so we've got C looking kind of like this, even though that line looks crooked there. It's actually got the same dimension as the purple that I've already drawn there. It's also 75 feet, and the back side back here is 135. Okay, cross-section D is parallel to the base and intersects the pyramid at 3/4 of the way up, so it is a little taller. All right, and its dimensions are 45 back here and 25 on the side. Okay, so now we can go ahead and write in the dimensions. At the bottom it says the pyramid from which the cross sections were taken has a front length of 180, and you can see that there. It has a side width of 100. You can see the side width right here. And a height. Now, we got to think about the height more than we have the other parts, because it tells me here that the height there is 30 feet. Well, it tells me in part C that that distance up is 1/4 of the way. So we can take 30 and multiply it by 4, and we get a height of 120. I know that that's a tough one, and I don't want you to get too stressed out about that one, because you more than likely will never see a problem like that again. All right, that's the first half of the recording, and click on the next link if you'd like to watch the second half of the recording.